Assalamualaikum. My name is Muhammad Razak Akmal bin Azman. My ID number is MA22138. So firstly, I will talk about the introduction of this project. In this project, we will create a virtual instrumentation system using a microphone and there's a lab software to analyze sound data in time and frequency domains. The microphone captures sounds from different sources such as no sound as a control, key rings for mentally impact, and fans for mechanical noise. And lastly, this setup helps us study the acoustic properties of each sound source. Next, for the objectives, firstly, to create a virtual instrumentation system with the ZLab software and a microphone to capture sound data. Second, to record and obtain from the three apparatuses sound wave data. And lastly, to analyze the data in time and frequency domains to understand the acoustic properties of each sound apparatus.
Assalamualaikum and very good morning. My name is Muhammad Aikadini bin Suhaimi. Today I will talk about my literature review. A microphone is an acoustic sensor that uses a diaphragm that vibrates in response to sound wave to convert sound wave into electrical signals. The electrical signal produced by the microphone is proportionate to the strength of the sound. Table fans with sensors like the Panasonic PF1801 have fan control sensors to regulate airflow, speed control sensors to maximize the performance, and energy efficiency sensors to modify operation based on real-time data. Now I will talk about the literature review for part 2. The industrial microphone that uses microphone are widely used across various industries such as music, telecommunication, transportation, and security. For music, the enhancing vocals, recording sound, amplifying instrument, telecommunication used in phone system, intercoms, and PA system. For transportation is to collecting the audio, communicating with passengers, enhancing driver safety. For security is to capturing sounds in surveillance system. Next, I will talk about the fan control sensors. There are two types of sensors in the fan, which is speed and for optimizing energy efficiency. Now, firstly, I will talk the fan control sensors. To the fan control sensor is to manage airflow within the instrumentation setup. The microcontroller modifies the speed of the table fan. Now, is about the speed control sensors. These sensors keep track of motor speed and dynamically modify it in response to load condition. Next is the sensor for optimizing energy efficiency. Table fans with sensors increase energy efficiency by dynamically changing their operation based on data from real-time sensors.
Assalamualaikum. My name is Muhammad Nasrul Zuhair bin Maknoh. My metric number is MA22051. And I'm going to present about the apparatus of the experiment. First, what we need for this experiment is a laptop, which we use to install the DaisyLab software and using the DaisyLab software to record the sound measurement. After that, we need a fan for the source of the sound. Actually, we need two item for the source of the sound, which is fan and key. Okay, to record the sound, we use a mini microphone. It has a sensor that used to record the sound from the source. And to compute the recorded sound, we use the DaisyLab software. The DaisyLab software used to set up the system and to get the result of the time domain graph and frequency domain graph. And lastly, we need a sound meter, which is an app, and we can use it by a smartphone. Next, we look at the experimental and software setup. For the experimental setup, it is pretty much very simple. We need a laptop and a smartphone. While for the software setup is quite complicated. First, we need to do the DaisyLab layout. Second, enter the measurement to set up the measurement. And then third, we get the actual reading from the Daisy Lab software. And then fourth, the actual sound wave will appear by the measurement setup that we entered before.
Assalamu alaikum. My name is Muhammad Firdaus Alam. My metric ID is MH21001. I will be discuss about the result for this experiment. In this experiment, we use one formula to determine the sound decibel from DaisyLab software, which is given below the result. For this experiment, to get the sounds, we use three situations, which is nothing, fish, and fans. We use two methods to record the sound decibel, which is sound meter app from mobile. Another one is DaisyLab software. So for nothing situation, we got 48.60 decibel from mobile, whereas from DaisyLab software we got 66.67 decibel. For keys, we got 60.27 decibel from mobile, whereas from DaisyLab software we got 90.87 decibel. For fan, we got for 84.20 decibel from mobile, whereas for DaisyLab software we got 89.00 decibel. So that's all from result. Thank you. So for discussion, I will be discuss about two graphs which we got from DaisyLab software, which are time domain plot and frequency domain plot. So for time domain plot, we got the highest and lowest value, which are 0.12 minus 0.1. Whereas for frequency domain plot, we got the highest frequency at 1400. So that's all from discussion. Thank you.
And lastly, for the conclusion of this project, the project analyzed sound data from ambient noise key range and fan noise using smartphone dB levels and DaisyLab software. It emphasized microphones roles and sensor adaptations in table fans for better energy efficiency. Overall, the study offered insights into sound properties and sensor systems enhancing fan efficiency. That's all from us, from our group. Thank you.